Little technical difficulty. My two things didn't want to talk to each other. So here's part 2 of your video. That last one we finished up by talking about 2 times does not exist is a does not exist situation. It isn't really accurate to say equals does not exist, so notice there's no equal sign in there. This last one now is quotient, so we're going to think of it as using the rule as x approaches 2 of f of x divided by the limit as x approaches 2 of g of x, and we're going to find those limits from our graph and divide. So the limit of f at 2 kind of looks like 1.5, and the limit as x approaches 2 of g is 0, and 2 divided by 0 is not really, allowed. So we would say that this is undefined or also does not exist because of a division by 0. So you would want to show those steps and then not leave your answer as 1.5 divided by 0, because we all know as good mathematicians that is illegal. So you'd want to take it a step further and either say that that limit does not exist or it is undefined. Okay, here's more functions. Polynomials. So polynomials do not have any sort of division by 0 or radicals in them, so they are well-behaved functions, and like it says here, you can use direct substitution. Rational functions, again, normally don't have division by 0. There's only one place usually that has a division by 0, so just be aware, and as long as you're not plugging in that value, you can use direct substitution. So that works for rational functions as well. So this first one is going to look like just that polynomial 4x cubed minus 5x plus 1. We are going to take 4 times our negative 3 cubed minus 5 times negative 3 plus 1. We're just doing direct substitution. Okay, so we're going to have 4 times negative 27 plus 15 plus 1. And I have a calculator here. So 4 times negative 27 plus 15 plus 1, negative 92 if I did my math correctly. Okay, the quotient, just check quickly. Does negative 2 make the denominator 0, or positive 2, sorry, make the denominator 0? It does not, so we're going to use direct substitution. So we'll have 2 squared, which is 4, minus 3 times 2, so 6, plus 4, over 2 plus 2, 4. And again, as calculus students, you can do a fair amount of this kind of simple arithmetic in your head, and that's totally fine. So negative 2 plus 4, 2 over 4, or 1/2 for this limit. Now, it's pretty important that you notice that there are equal signs between every single step. I am saying that this is the chain of work, and this is what happens. This line equals the next one equals the next one. Those equal signs are pretty important, so don't forget them. Okay, and the last one down here, we can take the limits of radicals. Now, any odd radical automatically works. If it's an even radical, like we talked about before, you just have to make sure that it's not going to create anything negative once you plug it in. So always try direct substitution first. So again, here, we can plug 0 in there. It's not going to make that a negative at all. So 0 squared plus 4 is square root of 4, or 2. Okay, so direct substitution really is our friend. Always, 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 you want to try that method first because it is the easiest. Okay, here's a really fun looking rule that's called for the composition of a function. So putting one function into another, like f of g of x, everybody's favorite. But check out what happens. You take the limit of the inside function, and then that numerical value gets plugged in to the function f. So this, we're going to use that same graph we were looking at before, and we're going to take the function evaluated at the limit x approaches 2 of g of x. So find that value on your table. The limit as x approaches 2 of g of x looks like this spot right there. So that's going to be 0. So this is f of 0. And now to find f of 0, we just look at the graph, and we're not looking at a limit. It's just straight up f of 0, so it's a point on the graph. Here's 0, here's f of 0, and it's you just kind of have to estimate that one because it didn't fall on a nice little grid mark. So maybe it looks like it might be 1.25 about. So that was, we ended up estimating just a little bit, but super fun. Okay, and trig functions. Trig functions are well behaved on their domain. So sine and cosine, you can always just plug in the c. The cotangent, secant, tangent, cosecant, all of those, as long as c is in the domain of the function, just use direct substitution. And here's some examples of different things using some of our properties from the lesson today. So pause the video here and see if you can figure out the same things as I did. All right, A here, we're going to take the limit as x approaches 2 of g of x cubed. So up top, I was given some of those values. So this one is going to be a negative 2 cubed. So a negative 8. Part B should be the square root of 4, so 2. Part C should be 2 times 4 minus 3 times negative 2, so 8 plus 6, 14. This one should be a negative 2 divided by 0, so undefined. Again, remember, do not box in negative 2 divided by 0. This one will be 3 times 4 over negative 2. 12 divided by negative 2 should be negative 6. And this last one kind of uses just all sorts of rules. We got products and quotients. So it would be negative 2 times 0 over 4. And this one is allowed because 0 can be in the numerator. That just equals 0. So hopefully you got the same answers I did. If not, let me know in class. Have a good day.